Okay. Before the session, I actually has reminded every one of you to print better for this lecture note, because we're going to fill up together. During fill up the blank space here, I'm going to explain to you so that you can understand the concept well. All right. So I really hope that every one of you here already have your this printed lecture note, because I'm going to use this as our reference. Okay. So the last lecture, what have we learned, everyone? Do you still remember the forces on? What have we learned the last lecture?
Forces on plane area.
Yes, the forces on the plane area. All right. So what do you think of the plane? Is it the straight line, having the curve, having any bending? The plane. So when we talk about the plane, it is the straight line. All right. Right now, you're going to understand the concept of the curved plane. All right. So this is the first point on the forces on the curved surface. All right. Now we look at the surface that has some curve. All right. Some curvature. For example, compute the resultant pressure force by separating into the horizontal and vertical component. All right. This is the explanation after we draw the free body diagram. All right. Let's say we have the curvature plane, right? Sorry, curvature surface. Okay. Let's see. Okay, this is much better. All right. Let's say we have the curved surface, such as like this. All right. Okay. And then we have this is the water. All right. This is the water. This is the water inside this. All right. So this is just a curvature surface. So what do you think of forces going to act on this surface? Definitely the force will be perpendicular to any surface, right? So previously we learned about the plane surface. So how to solve for this kind of curvature surface? So what do you think, everyone? Do you have any idea on how to solve the curvature surface?
Break it down into components, then find the result.
Pardon?
Break it down into components and then find the resultant.
Yes, perfect. Okay, that is correct. You need to break down. So how to break down? You need to have the projection into the vertical and horizontal axis. So let's take a look of the projection in the horizontal axis. So this is the horizontal. Okay, let's say this is the all right, this is X and this is Y. This is horizontal. When we do this of the curvature, we need to break down. So how to break down? We have to project what is the horizontal axis. So this is horizontal. We project this one, this curvature into horizontal. So that means this is the projection line. Okay. And then what happens when we do the projection into the vertical axis? So this is the projection. Okay. This line we call the projection line into the horizontal and vertical axis. So what you can put it here is that you can name here as the projection. This is a projection of horizontal. All right, this is projection of vertical. All right, so far you understand, yeah, the concept. All right, this is how you solve for the curved surface. That means you try to do the projection of the horizontal and vertical axis. Okay, so to make it clear, let's draw the free body diagram. All right, this is free body diagram of the fluid block. For example, in this portion, I try to take it down. All right, how to do that? Just take it out at the internal side of the projection. Okay, this is the curvature. Okay, sorry. This is the curvature surface. And then the projection is this. All right. Okay. So what do you think of forces involved in this? We call as a fluid block. What do you think of the force involved? What kind of force do we have? The weight, perfect. And which location? The weight acting on the centroid. Center of the block. All right. Okay. Do we have any other forces, everyone?
Pressure. Component
Yeah.
force.
Yes. Which component? Horizontal and vertical.
Vertical.
Yes, this is the vertical force. Remember, the vertical force will be like this. Okay, this is the vertical force. Okay. So definitely we have the resultant force. Okay, this is what we call Fx, because it is acting horizontal. Do we have any other forces, everyone? We have this one, horizontal. What do you think of the distance here to here? Is it the same or different? Remember horizontal? Is it the same or different? Yes, the horizontal force inside the fluid always the same, except the height or the depth. Okay, this is the force. Okay, the pressure force. Do we have any other forces, everyone? There should be a reaction. There should be a reaction force to counter this force. Fy and Fx. What do you think of, where's the location of force to counter back the Fy and Fx?
On the curve.
All right, on the curve. All right. So we have the forces acting on the curve. It is always perpendicular. All right, 90 degree. 90 degree. Okay, because of this having a different direction, so simply we put only one reaction force. We call as the FR, resultant force. All right. Okay. So from here, we have complete all the forces required to make sure this block under the equilibrium state. Okay, without this reaction force, this Fy and Fx will push and this block will move. All right, we don't want this block of fluid move. We need it to be static or equilibrium. So to make sure this is under the equilibrium state or not moving, we have to counter it with the resultant force. Okay, everyone, so far understand?
Okay, doctor.
Okay, so can you see this resultant force having the slanting direction? So we need to separate into H and V component, right? So from here we separate FH and FV. Okay, so as usual, we apply the summation of force in the x direction equal to 0. Why equal to 0? Because we want to make sure this is under equilibrium state. Okay, everyone. Equilibrium, right? So what's the force? Can you write it down? What's the force involved in the x direction? Right, positive to the right is FH minus
Fx
equal to
0.
0. So FH equal to Fx. Okay, what happened for the vertical one? Okay, so you should have a direction upward positive summation of forces into y component equal to 0, right? So please tell me what's the forces?
Fy.
Fy negative or positive?
Negative Fy, negative W plus F.
Negative Fy, negative W, positive
Positive
F
Fv.
equal to 0. So rearrange back, you will get F, V, vertical should be equal to, which one? Fy plus W. Okay, so far clear about this, everyone?
Yes, doctor.
Yes,
Okay,
Yes, doctor.
do you have any question?
No,
So good.
not yet.
Okay, if you have, please let me know, alright? Okay,
Doctor,
this is, yes?
for the curvature line, so we will have only one resulting force there, right?
Yes. Yes, we only have one resultant force. This resultant force represent all these forces, this prism force. Okay, we take a look only resultant, the final result. This is the combination force. Okay.
Okay, doctor.
This is the resultant, the red line. This is the resultant, the red line. Okay. This is also the forces involved. So from here we break it down. Okay, everyone. I think this is basic concept for static that you have learned previously, right? You learn the static. So you learn static and then you apply to fluid mechanics. So that's concept you please do not forget. Okay. So this is this is the general rule. All right. As I mentioned before, the horizontal component of hydrostatic force equal to hydrostatic force acting on the vertical projected of curved surfaces. Alright, so that means this FH equal to Fx. You can see FH equal to Fx, where Fx acting on the vertical projection. Can you see here? On vertical projection. And then the vertical component of hydrostatic force. Okay, this is vertical component equal to the force of the force acting on the horizontal. So this is correct, Fy, acting on the horizontal projection. Okay, plus minus the weight of the fluid block. So this is the weight of the block plus. Okay. So let's take a look of the example 12. All right. Okay. So please read first and understand. Okay, everyone. Compute the horizontal and vertical components of the hydrostatic force on the quarter circle panel at the bottom of the water tank. Alright, so what's the question asked? Everyone? What's the question asked?
We must draw the FBD to find the components, the horizontal and vertical.
Okay, yes, the question asks find the horizontal and vertical of hydrostatic force. Okay, clear? So, from here, what you need to do? Please tell me the first step.
Find the forces.
We draw the FBD.
Yes, correct. Please everyone draw the free body diagram. All right. With the free body diagram, you can assign the forces. Okay. So what's the free body diagram here? It should be the projected. Okay. So from here, I try to project my curve. All right. Your projection should be into the water. Okay, this is inside the water. Not project here. Okay, this is wrong. Project into the water because you need to consider the block of fluid. If you project here, you consider the block of air. Alright? So, this is how you project. This is the horizontal projection and this is the vertical projection. Alright, this is your, what we call, the block of fluid, the fluid block. So, you draw your projection. Okay. All right. So, from here, you can assign the forces involved. Okay, what's the force involved here? You have the horizontal and vertical forces, right? Okay. So, let's draw the force. What happened to the horizontal force? Where's the location?
Below the center.
Yes, perfect. Below the centroid. By what value? YCP equal to?
Negative Ix6. Negative Ix6 sine theta divided by HC into A.
Yes, good. Now I can see you revised back my previous lecture, not? That is very important, okay? So, from here, this is centroid, okay? And the horizontal force should be acting below the centroid. This is F. Okay, let's say this is have a H. Okay, FH. Okay, do we have any other force?
The weight and the vertical force.
Okay, this weight, right? Okay,
Yes, sir.
so
Yes, sir.
for this case, you need to look at the weight. Do you think the weight above here is considered as the hydrostatic force? Above this projection?
Yes, Doctor.
Yes, because we have this kind of weight, right? Everyone.
Yes, Doctor.
Okay, this weight give the pressure to the curvature. So we need to draw another block. Okay. Okay, sorry tak cantik. It's not. I try to draw nicely. Okay. Okay, this is the. Okay, and then can you see this is what we call here? What we call this? This is the reference. This is what we call as a reference line or datum. So when this considered as a reference line, that means the atmospheric pressure equal to
0.
0. Okay, everyone. we are considering the absolute or gauge pressure.
Gauge.
Gauge. Why gauge pressure?
Because the reference line is on the atmospheric.
Yes, perfect. Pandai pun. Okay, so our reference line always at the atmospheric when we consider as the gauge pressure. Okay, so from here, okay, let's say we have the weight. Okay, the weight of the liquid on top of this curvature surface. Do we have any other forces?
Toward
Everyone?
the curve. Force
Okay,
toward, yeah.
force dekat the curve, right? So we have the reaction force. Okay, let's say we have this F R. So because of Fr, we separate into X and Y component. Maybe Fr, okay, Frx, Fry. Okay, so from here, compute the horizontal and vertical component of hydrostatic force. Okay, so summation of force in the x direction equal to 0. So what's the force involved in the x direction? Which is FH, positive FH, and then
minus FRX.
minus FR x equal to 0. Okay, so we can say that we can say that Fr equal to FH. So this is FH that we are looking for, which is horizontal component of hydrostatic force. So what's the formula of FH? FH, previously we learned gamma of fluid multiply with gamma of fluid multiply with all of you forgot already.
HCA.
Area. Okay. For those just joining or not understand for this, please look at my recording lecture video, right? I always post after the class. Okay, please look at the e-learning. You can see the link of the video recording. Alright, so what is the gamma? Gamma of water. We use the SI unit. You can see we have meter. What's the gamma of water?
9810.
Yes, 9810. Okay, what is the HC? What HC represent? The height of?
Surface to
Distance from the
centroid.
center to the centroid.
Yes.
From the reference
height.
line.
This is centroid height, which is the height from the surface to the centroid. Okay, can you see this is centroid? So from here to here is H
6 meter.
C. So what's the value of HC, everyone?
6 meter.
Okay, 6 meter. Do you know why 6 meter, everyone? Because this is the center, right? Centroid. Alright, from here to here is 5 meter. And from here to here is half of 2 meter. So 2 meter divided with 2 is 1 plus 5, which is 6 meter. Okay, everyone? Understand? Okay, clear so far?
Yes, doctor.
Yes, doctor.
Yes,
Okay. So multiply with the area. Area of the projected surface. What's the area of which area? This area or this area? A or B? A or B? Which area that we consider now? A.
Oh, A.
B,
A.
A.
Both
A. So
A
what's the
sector.
value of this projected area? When we try to draw here, it will be like this. Okay. Okay, what's the value of this?
Rectangle.
This is 6 meter. What's the height of this?
6 times 2.
6 times 2. Alright, so 6 times 2. So 6 times 2. Alright, please help me calculate. So what's the value?
Seven or 6.
7 or 6.
3 to 0.
3 to 0 Newton. Okay, this is the final answer. Or you can make it a kilonewton. Okay, put it here kilo and divide with 1000. Okay, everyone, clear? Okay, so far until the summation of forces in the x direction, you guys understand how to get the FH? Every one of you?
So far,
Yes. Sir, can you please repeat how you get the H6?
Okay, how I get the H? Okay, what is the H by definition?
H. This. No, I'm not really understand. Yeah.
Okay, what's your name?
I know.
Ali,
I know.
Are you just joining my class?
Yeah, actually, I couldn't join your class for a couple of times.
Okay. Okay, because I wonder, my previous lecture, I already stressed what is the HC. Clear, everyone? Previously, I explained the HC, right? Okay, never mind. The HC, okay, please look at here. HC is the height of centroid. Alright? So, when we refer to the gate system or any kind of plane, for example, we have the plane. Okay, this is our plane. Where is the centroid? What do you think of at the middle? Okay, this is we label as the centroid. So, if this plane submerged into the water, okay, we have the water, and then what do you think of the centroid? The height of the centroid definitely start from the surface, free surface, to the centroid. This is what we call HC. Okay, so far this part you understand?
Yeah.
Okay, how about this? Okay, can you see this is the plane? Okay, this is our plane. Where's the projected? The projected of the vertical. This is projected, right?
Yeah.
Okay, this is projected. Okay, this line, this plane is a projected plane. Okay, so where is the center of this projected plane?
In the middle.
At the middle.
Yeah.
So again, this plane submerged into the water. So this is water. From the free surface of the water to the centroid, we call as the HC. So from here, from the surface to here is what's the value?
5.
5. Can you see this 5?
Yeah.
Okay, from here to here, what's the value?
1.
1. So, can you see?
Understand.
Okay. So far, everyone understand? Every one of you?
Yes, doctor.
Yes, doctor.
Yes, doctor.
Okay, clear
Yes,
ya so far? Crystal clear ya? Okay. So this is how you get the horizontal. Okay. And how to get the vertical. Okay, so we apply the summation of forces. Let's apply here. Okay. Summation of force into y vertical equal to 0. Okay. Positive. Okay, please help me. What's the force involved in the vertical? Please start with the positive first. What's the positive value?
FRY.
FRY
F-R-Y
minus weight.
minus weight. And then?
Equal to 0.
Equal to 0. So F-R-Y equal to weight. So what's the weight? Weight of what? Weight of what? What need to be subtract? Weight of the... What do you think of the weight? Weight of what?
Weight of the fluid. Which is water.
Yes,
Uh,
that is
mg?
weight of... what?
Mass,
Sorry?
mass into gravity.
Yes, that is a formula. I ask you the weight of the which block you consider? This block A, or block B?
The upper
Block
one.
A. Block A.
Block A.
Block A.
Block A or block B?
Block A.
Block A.
Okay, why block A?
Because block A is exerting force on block B.
Okay, block B don't have any force?
Got also.
Yes, got
Yes.
also. So what do
Yes.
you think?
It
Block
was
A or block B or both?
Both.
Both, okay. Block A and block B combine together to produce the weight force. Okay, everyone. Acting on this.
Maksudnya satu weight je lah, doktor.
We consider only one weight. If you consider A, how about B? B also have the weight. Betul tak? B
betul,
also
betul.
generate weight. A also generate weight. So what do you think of the weight? The total?
The total summation.
The total summation of weight A plus weight B. Okay. So how to get weight A and weight B? Any formula? It is given quarter circle.
1/4 the
1/4
times with the mass
the cross-sectional area of the
circle times G.
Time the that is the formula. Okay. Okay, let me draw here. Okay. So my mission here want to get this volume. All right, I want to get this volume only. Because what's the formula of weight? Mass multiply with
G.
Gravity. Perfect. Okay. Mass multiply with gravity. All right. We know that density equal to mass over volume. So mass equal to density multiply with volume multiply with gravity. So weight equal to rho Vg. Okay, this is the basic one. Okay, everyone.
Yes, doctor.
Okay, combination of density with gravity, what we get here? Density gravity represent
Gamma.
gamma. Represent this, okay, gamma. And then volume. Okay, so what our step first. What we need to do here? We need to find the gamma or we need to find the volume? Volume of the block.
The volume?
The volume. Why you need to find the gamma? Because the gamma already given. This is water. 9810. Okay? So what you need to find is the volume of this block. Block A plus block B. Alright? So this, let me draw the volume. Okay, how to get this volume? This is based on your secondary school.
We combine shape A and B, subtract from them the area of the circle, and then circle volume formula.
No.
Good. Okay. That is interesting. So how to get this volume?
Volume of cuboid minus 1/4 volume of cylinder.
Yes, perfect. So the volume of the block, right, everyone? The volume of the whole block. So the volume of the whole block, rectangular, minus the volume of
cylinder, 1/4 of cylinder.
Yes, the volume of the quarter cylinder. Q C.
Doctor, what I said was also the same thing.
Okay lah. Okay. Okay. Thank you.
Yeah, the circle one is also the same thing.
Okay.
That guy said no.
Okay. Okay, both of you correct. Okay, thank you very much. Okay, so please help me how to find the V of R. So I continue here with equal to gamma, which is 9810 multiply with the volume of subtraction. So this volume. So how to get this volume of rectangular?
6 into 5 into 2.
6 into 5
into 2.
Are you sure? The whole
block.
No,
sorry, 6 into 7. 6 into 7.
7.
Yes, 7. If you put 5, that means you consider A. Okay? 6.
Yeah.
6. 7.
Yeah.
Into?
2.
Which one? Sorry. These two. Okay? So this is 7. This is 2. And this is 6. Alright, this is complete bracket. Minus what? Quarter of circle. This quarter. So what's the formula? Quarter. 1 over 3, 1 over 2,
4.
1 over 4. Okay, what's the area here?
5 2R
over
square.
4 pi r
2 squared. Pi r square h.
Pi r squared. Alright.
Pi r
H. So what's the value of r?
2.
Everyone, what's the value of r here?
2, Doctor.
From here to here.
2.
Okay, remember these are always same with this r. Okay, so 2 squared, and then multiply with the
6.
Multiply with this 6. Okay, everyone. Okay. Okay, what's the value?
639125, Doctor.
Yes, perfect. 639
125 or 6
kilo
Newton.
Okay, so far you guys understand how to get the force, horizontal and vertical. Everyone, why silent je? I want to see your feedback. Do you understand? Okay.
I understand.
Yes, doctor, we understand.
Okay. So once you understand, it's pretty easy, right? You can solve anything. So this is just an example. Okay, for this part, I'm going to show you in the tutorial, okay? Okay, we take a break. Maybe 2 minutes. Okay, and then we continue, yeah?
Doctor, can you open the example 12? I just need to copy this.
Okay, you can copy. Okay, everyone. I think we shall continue. Okay, so every one of you complete your writing this up. Okay. So can you see this example? If you know this concept, definitely you can solve this, right? Believe me, the concept is the same as I explained just now to you. Okay, this will explain in the tutorial. Please look at this tutorial, and at the end of this week, I'm going to give you the quiz. All right, but the quiz will be conducted in the e-learning, where I will have the time duration for you to complete. Okay. Okay. Now we proceed to the second module, which is buoyancy of submerged and floating bodies. All right. This Archimedes, the professor, the scientist, I believe you know who is the Archimedes, right? Discovered two laws of buoyancy. The first one, a body immersed in the fluid experiences a vertical buoyant force equal to the weight of the fluid it displaces. Okay. You guys, are you there?
Yes, doctor.
Yes, doctor.
Okay.
Yes, doctor.
Okay, why suddenly... Okay. Can you see my screen?
Yes, doctor.
Yes.
All right. So let's say, yeah. Let's say you have, okay, I would like to explain more on this. Let's say you have a beaker, the water. Okay, you have the water inside, and then you have one object. You submerge one object. Okay, and then this object float in this position. Okay, for example, your rubber or anything else. Okay, so this is water. Okay, so what the Archimedes said here, a body of Immerse, a body. So this is body. Alright, immersed in a fluid experience. Experience what? The vertical buoyant force. Alright, so where's the vertical? This is the vertical. So this body experience the buoyancy force equal to the weight of fluid it displaces. So that means, okay, initially, this is the fluid. Alright, this is the fluid. When you try to immerse one body, what do you think of the fluid? Do you think the fluid will go up? Or good, or the same? Anyone?
Go up.
Okay,
Go
why go
up.
up? Why go up? Because you put additional
Volume.
volume. Correct. So because of this, you try to put a body immersed in the fluid. So that means you put additional volume. Alright. So that means you remove this portion and you replace with the other fluid. So that is why the vertical buoyant force equal to the weight of the fluid it displaces. So what it displaces? It displaces here. The same shape, but this is fluid. Okay? You guys understand? Displace. Displace
Yes,
or
doctor.
replace. Okay. So this is the, for example, this is rock. This rock displaces this portion of fluid, and you can see this is the portion. Okay, so this displace of the fluid have the weight, right? Right, everyone. This displace of fluid have the weight. So this weight and this buoyancy force is equal. Okay, this is what the principle of buoyancy. So far, you guys understand?
Yes, doctor.
Yes, doctor.
Okay, good. All right. And the floating body displays its own weight in the liquid in which it floats. All right, this is what I explained previously. Okay, so let's consider, okay, this is considered the free body diagram. For example, we have the water here, water surface. Okay, and then we have a body, or we call a rock or something else. All right. So from here, okay, let's label here as a point A. For example, this is point A. Sorry, this is point A. Okay. Let's label here as a point D. Okay, this is point C. Okay, this is H. Okay, maybe this is H. And this is K. And vertically, we draw this line. Okay. All right. So let's say this is point A, point B, point C, point D. Okay. And then what do you think? Do we have any forces involved here? Everyone?
Yes, doctor.
Okay, what's the force involved?
Force toward the body, toward the surface.
Toward the surface. But upward or downward?
Upward.
Okay, let's say we have the force upward. F, maybe Fz. Okay, and we also have the force from here. Fz. Maybe this is Fz, this is Fz prime. Do we have any other forces?
Weight.
We have weight acting on the
centroid.
centroid. We have the weight. All right, so this is what it means. And then we have since this is water, we have the gamma of water, gamma of fluid. All right, the gamma not always the normal water, maybe the sea water, maybe oil, or maybe mercury. So it depends on your case. Okay, so from here, forces on the immersed body are the gravity. Where is the gravity? This way. And the pressure of surrounding fluid. So this is the pressure. You can see the vertical pressure surrounding the fluids. Okay. So upper surface. Where is the upper surface? Where's the location of upper surface?
Upper surface.
Yes. Upper surface of the body. D, H, and
C.
K. C. D, H, and C. This is the upper surface.
Oh.
So what's the force involved in the upper surface?
Fz.
Fz. So from here you can write it down. The vertical component of force. Okay, components of force. Okay, which is F Z equal to the weight. What's the weight? The weight of fluid volume what is the weight? The Fz equal to what's the volume involved? Equal to the volume of A, B. How to get the Fz, everyone? How to get the Fz? Fz equal to the volume or the weight of what?
The weight of the object.
Okay. So where is the location of Fz? On top of this? On top of this surface, right? So what's the pressure involved? So what's the force involved?
Force.
Pressure of the water?
Yes, correct. Please continue. The weight of
water.
Which water? Which location? A, B. A going to be the weight of what? The weight of the water.
A, B, C,
okay?
D.
A, B, C,
D.
D. H involved tak?
Involved.
So it involved. Okay, if you say A, B, C, D, that means this is cross. Okay, so that means it consider Fz is actually equal to the weight of the water above the surface, top surface. So this is the what's the force involved here? A, B, C, H, and D. Okay, so far clear?
Yes, doctor.
Yes, doctor.
Yes, doctor.
Alright. So how about the lower surface? This is lower surface. What's the force involved?
Buoyancy.
Okay, Fz prime. Okay, so you can write it down. The vertical component of force, which is Fz prime, equal to the weight of fluid of the fluid what? Remember previously I taught you on how to calculate the pressure at different elevation. So how to get this pressure? What's the value here?
Fluid yang terkeluar.
Okay. Okay. How to get the Fz? Fz prime equal to in order to get the Fz prime, you need to find the fluid weight of A, B,
CHD.
C,
HD.
H, D.
D.
Where is the B?
D.
D. So that means K involved?
Tak, sebab dia weight of fluid atas tu.
Okay.
Tak Involved.
Okay. Basically, consider this is a fluid as well. Okay. Which fluid point involved? A. In order to get Fz equal to
A, B, C, K, D.
Yes, perfect. So A, from A, the whole of this.
Faham.
Okay, faham tak everyone? Understand? In order to get Fz prime from A, B, C, K, and D. So you name it. Okay. A, B, C, K, and D. That is very simple. Okay. So the difference between two volume. The question asks, what's the difference between two volume?
Dia punya kalau volume.
The different. What we call D, A, or DH. The difference between two volume.
DHCK.
Yes. So DHC. Okay. So this is the difference, right? So. Here. Volume of body. D, H, C, and K. Can you see the difference between two volume?
Yes, doctor.
Okay. So far you understand, yeah?
A, B, C, D minus dengan yang
yes. A, B, C, K, D minus A, B, C, H, D. Then you get this.
Dapat seketul batu.
Yes, perfect. So you dapat ni, you get all this. This is the different. Okay. Clear? Okay, now look at the buoyancy. Okay, I try to guide you step by step to understand the concept of buoyancy. Okay, now look at the buoyancy force that is denoted by FB. Okay. FB, okay, FB is always acting vertically upward. This is the standard, right? Because to support the body to float, all right? Because you can see once you immerse one body, you will realize that this body will float. The float because of what? Everyone, when you try to immerse object into the water, what do you realize?
Realize immerse air keluar.
Immerse air keluar, and then this may be floating, right?
InsyaAllah. Floating.
Floating because of what?
We have buoyancy forces.
Yes, because of this buoyancy force, right? Always acting vertically upwards and actually equal to the Fz prime minus Fz. Alright, can you see here? This is Fz minus Fz prime minus Fz is actually you will get the weight of the fluid in which it turns to be the buoyancy force. Okay. Okay. So from here, FB, actually to calculate the value of FB, buoyancy force, Fz prime minus Fz, okay, in which equal to the weight of the volume, okay, of fluid apa? Volume of what? The different?
The fluid displaced.
Fluid displaced.
Displaced. Which point? DH?
DHCK.
CK. So we can say that this displaced fluid, which is DHCK, is equal to the buoyancy force. All right. Like I explained to this concept, can you see? Once you try to immerse one body, you can see the water fill up, going up, and then this portion, this hole, all right, will be displaced with this rock, and you can see this is the fluid. And then this fluid having the weight. So this weight is actually equal to buoyancy force. This is what I explained to this. I explained to this lah, right? So buoyancy force, okay. Okay. Right. A buoyant force on any body is equal to the weight it displaces. So simply for you to understand, just remember buoyancy force equal to the body, to any body. Buoyancy force on any body is equal to the weight of displaced fluid. Okay, that is what the definition of buoyancy force. Okay, in which the formula it turns to be FB, F subscript B, buoyancy force is equal to gamma of fluid multiply with the volume. Volume of what? Volume of?
The displaced, fluid displaced.
Volume
of displaced.
pH.
Volume of, in which V here represent the volume of displaced fluid. Okay, not the volume of the rock. Okay, everyone, don't misconcept, yeah? Not the volume of the rock. For example, let's say this is the cup of water, and then you have the rock here. This is not the volume of this. The volume of the fluid displaced. Alright, so this rock will displace this fluid. Okay, everyone. This weight is equal to the buoyancy weight. Okay, so far clear?
Clear.
Okay, bagus. Good, everyone.
Maksudnya volume water displacer tak sama dengan volume rock lah kan?
Tak sama because of good question. Why the volume of
density?
Sorry, the volume the same, but the weight. Why the weight of the fluid not same with the weight of the rock?
Density berbeza.
Density because of the ketumpatan. Density of the rock higher than the density of fluid.
Faham.
Okay. Okay, and then we take a look of the case. If, this is important. If the weight is more than the buoyancy force, the body will sink. Okay, for example, this weight. Okay, for example, this weight, such as the weight of the rock, is more than the buoyancy force, this body will sink. Okay. Because because of the weight of the rock is higher compared to the buoyancy. I think this is common sense. If the weight of the object, for example, what do you think of the weight of the object is less than the buoyancy force, the weight of the water? Example, yang ringan-ringan, which is light, the weight of what?
Piece of wood.
Leaf.
The leaf, okay. The weight of?
The weight of the volume of the.
Okay, for example, this is water. What do you think of the? What do you think of the density which is less than the density of the water?
Maksud doktor macam oil macam tu.
Yes. So oil have the
low density than water.
Okay, so that is why the oil can float on top of the water.
Oh, faham?
Okay, so we can see here. Okay, this is oil. Alright, because of the buoyancy force, it tries to separate the density of the oil with the density of the water. Alright, so because of the density of the oil is lower than the density of the water. That's why it can float. Alright, so this is what it means lah. Alright. Okay, so from here, FB pass through the center of the volume of the displaced body. So that means the FB always acting on the centroid of the volume. Okay, the center of the buoyant label with B or CB. So for example, you have the centroid, you will name as C or CB. That's it. Okay. Okay, this is very important. Layer fluid. For example, you have a cup of different fluid. Okay, this is maybe oil. This is oil. This is H2O, water. And then you have the floating object. Okay. So what do you think of the buoyancy force? What's the buoyancy force equal to? Equal to the volume of the?
Both fluid, oil and H2O.
Yes, equal to the volume of both. Oil will have different density. water will have different density. This is why, okay, you can put it this way. F of buoyancy is equal to summation of gamma I of VI. For example, for this case, gamma of oil multiply volume. Which volume? For example, this is A, B, C, D. The volume of what?
Apa?
Okay, multiply with the volume. For example, gamma of oil multiply the volume displaced. What's the volume?
Volume of ABC lah.
A, B, C. Plus gamma of water. Volume of what?
Volume of
ACD.
ACD.
Boleh.
Nampak tak? Simple. Can you see it is simple on how to calculate the layer fluid. Okay. So this is what it means. Each layer has its own center of volume. Okay. That means this have the different centroid. Why? Why have a different centroid? Because different density, fluid density. The density will lead to the mass. Can you see that density equal to mass over volume? Different density will have different mass. Okay. The mass will give you different center of volume, centroid. Okay, so far you guys are clear on this part?
Yes, Doctor.
Okay, we almost finished, don't worry. Okay. Okay, now we go to the final part, alright? So the floating body. Consider a body in a liquid with a free surface. Okay, if its weight W is less than of the same volume of the liquid, it will, okay, this is the answer. Alright, let me draw the free body diagram. For example, you mean the floating, alright? I mean the floating means this is the surface, okay? And then we have the body. Okay, this is the body. And then let me label here A, B, this is H, this is K. So please tell me where is the forces, buoyancy force. Where is the okay, where is the force involved?
On K.
Which one?
On K.
Okay, on K, correct. So we have the force, okay, F, force, and then we have, what do we have here?
The weight.
The weight. Okay, FP point upward is equal to the weight. Okay, let's say we have the weight. The weight of this body. Do we have any other forces?
The atmosphere.
Do we have atmospheric pressure? Okay, why do we don't have any atmospheric pressure? We consider
reference.
Okay, once you see this reference line, that means atmospheric pressure P atm always equal to 0. Okay, because of this symbol. Okay, everyone. So we have the fluid. You have the fluid. All right. So this is what it means. Okay. So from here, this is what the floating body. This is okay. This line we call as the free surface. Okay, you must understand the definition. Okay, like before, gravity and pressure force act on the body AH, ABK. Okay, like before. Previously, we know that the buoyancy force acting on this body complete, right? DHCK, all. However, if we have the floating body, that means this is half. Half above the free surface and below the free surface. So what do you need to do? Okay, like before, gravity and pressure forces act on the body, complete body, AH, BK. So for this case, Fz prime, okay, for example, the previous one, Fz prime equal to the weight of the volume liquid AKB. Okay. Alright. So what do you guys understand of this? Fz prime equal to the weight of the volume liquid AKB. Okay.
Macam mana, Doktor?
Okay. What do you understand? Fz prime, which is here, equal to the weight of the volume liquid AKB.
Oh, sama je lah. Sebab AKB tu volume yang fluid displaced.
Okay, good. Pandai. Okay, what do you think of the displace? You try to draw. What do you think? This is the displace. Okay, boleh nampak tak everyone?
Boleh, Doktor.
Okay, which part displace? This part or this part? A or B?
A, Doctor.
Bawah, yang bawah.
At the bottom side. So this is, we call a displace volume. Do you think this part displace? Displace the liquid? No, because this is above the water. So it will not displace the water. Below the water, displace the water. Okay. So this part we call as the A, B, and K. Or A, K, B. Okay. So this is what we call AKB is equal to Fz. Okay. So this weight have the weight, right? Having the weight and the centroid. So this weight of the fluid it displaces is equal to what, everyone? Equal to?
Fz prime.
Yes, Fz prime. So Fz prime now change because this is floating. Fz prime equal to the weight of the fluid it displaces. What the displaced fluid? This one. Consider the A color, not the whole of this body. This is wrong, yeah? If you consider the whole of this volume, then totally your answer is wrong because the whole is not displaced the fluid, only the bottom side. Okay, so the bottom side of the weight equal to this, Fz. Okay, so far you guys clear on this?
Yes, Doctor.
Okay. So FB point upward and equal to the Fz. So we can say that this Fz ni, because this is the same as the buoyancy force. So FB equal to Fz prime. Okay. So just like with the submerged body FB is equal to the liquid displaced even if the body is floating. So, okay. Alright, so this is what I explained. Floating body displays a volume of liquid equal to this, equals to the weight. Okay, so under the equilibrium, that means the object is static, not floating, not sinking. The wake and the buoyant force must be equal and opposite. Okay, must be equal. So for this case, we neglect the atmospheric pressure on the floating body because we have the reference line. So the same thing happen. The formula of buoyancy force, FB, equal to the gamma multiplied with the volume. Okay, for this case, this volume or this volume, A or B? Everyone.
B.
Volume of what? A or B? B or A?
B.
B of course.
B.
B. Who said A? I heard someone said A. Marai, are you say A?
No, I said B.
The B. Okay, because only B at the bottom of the water. So definitely this B displays the water volume. Okay. Okay, I think that's all for today. For this tutorial part, okay, I'm going to show you step by step on this tutorial. I will promise to you I will upload this section. Example 13. Alright, for the curved surface, as well as for this example 14. Suspended of the crane, as well as for this. For this lah, I try to upload for this. Okay, everyone. So far, you guys understand? Concept?
Understand, Doctor? Yes.
Understand, Doctor.
Okay, so basically, if you understand, you can go through a lots of example lah. So you know already the buoyancy force is equal to the weight of it displaced, the displaced volume. Okay. So I think that's all. We end our session, which is actually cover this week lecture, which is the curved surface and the buoyancy force. Okay, for those unable to get your attendance, please do so before we close our session. Do you have any questions so far? Okay, at the end of this week, I'm going to give you two important tasks. The first part, the quiz, which will be done through e-learning, where I will set the time limit that you need to accomplish a series of questions. Please be honest while do so. And secondly, I will post the forum question, first come, first serve, for this week lecture, which means cover the curve of the force, the force on the curved surfaces, as well as the buoyancy. All right. So for the task forum, this week I'm going to record your responsibility, and I will assign you a mark for that. Okay, for those just joining the session, my session, normally I will assign the forum question, which is you are compulsory to post at least 3 questions, and you yourself need to answer your friend question of 6 questions. All right, so you post 3 questions, and then you go to your friend forum and answer your friend forum 6 questions, right? At least 6. The more you answer, I will give you more marks lah for that. So far clear on this?
Okay, Doctor, clear.
Okay.
Doctor?
About the schedule, right? Okay. everyone, do you think can we have the replace of during Ramadan on the first? Okay, this is only Ramadan only. Can we make it during the lunch hour? Except I think lunch hour because you because some of you can we make it on a Monday, Tuesday and Thursday lunch hour? Is it okay?
Dr. Lancher, you mean at what time?
1 to 2.
Monday 1.
I'm okay with it.
Okay, only 1 hour, simple.
Boleh sir.
Boleh Only 1 hour.
Boleh.
During Ramadan.
Only Ramadan.
Boleh.
Siapa kata nak lunch tu kantor.
Boleh doktor.
1 hour from 5 to from
1 to 2 Amar.
1 to 2 only. Every Monday.
From 1 to 2.
Yeah.
Yes. Monday, Tuesday, Thursday. Okay.
Monday, Tuesday,
Thursday.
From 1 to 2.
Yes.
1 to 2.
Boleh.
Or you not
Okay.
fasting Amar? You better tell me.
Okay.